Hello everybody, welcome back to another funky fresh episode of the beautiful channel Beau Maths. Hope you're all having a fantastic day so far, and today we are going to continue talking about proportions and percentages as kind of this really important application of fraction multiplication. We've discussed this for the last several videos, but it's important, and hopefully through this you've been feeling more comfortable and confident with the ideas of fraction multiplication and all the perspectives that we can get on them. In the last video, we talked about percentage and how percentages are basically just standardized proportions. And today, this video is going to be kind of a small little one-off topic where I just kind of give a little bit more details on how we can think about percent. And particularly, I would like to kind of talk about how we can use some ideas from percentages and proportions to look at equivalent fractions. So, to do this, let's just consider a situation. Alright, so suppose I have 5 children and one has polydactyly. Polydactyly is where you're born either with some extra fingers or extra toes. It's kind of interesting that it happens more commonly than you'd actually think. But yeah, so this is just the condition where you're born with an extra one of those appendages. And I'm asking, what proportion of my kids have polydactyly? Okay, so we know how to do this. We just take the total as the denominator, which is 5 kids, and the numerator, which is the amount who has polydactyly, which is only 1 in this case. Alright, so that is our proportion. That's simple, we know how to do that. That's review. Now I'm going to do this again, but I'm going to change up the numbers. So, suppose now I have 10 children, and that 2 have polydactyly. What proportion of my kids have polydactyly? Okay, so I just used lines to kind of indicate that I'm just copying what was above. It's the same question, but now with 10 and 2 having polydactyly. So the total now is 10, and the amount that actually have the condition are going to be 2. And 2 out of 10, we know, can actually be simplified into 1/5. So it's actually the same proportion as with the first question. Now I'm going to do this again, and then I'll tell you why I'm kind of doing all of this. So suppose now that we have 100 children, and that 20 have polydactyly. What proportion of my kids have polydactyly? So now what we do is we take our total that have the condition, which is 20, out of the total amount of children, which is 100. We have 20 out of 100, and once again, this can be simplified down into the same proportion of 1/5. So what's the point in me asking this? Well, notice, if we just go right to the simplified fraction, we kind of lose information. If I just say 1/5 of my kids have polydactyly, that could be referring to the situation where I have 100 kids and 20 of them have it. Or it could be referring to the situation where I have 10 kids and 2 have it. Or it could be referring to the situation where I have 5 kids and 1 have it, right? So essentially, by just using this proportion here, we lose the context of how many kids I actually had. So there's a couple ways that we can go about this. So the first method would be to look at what we did in Plumper proportions, and we saw that we could apply proportions to groups of different sizes and basically figure out what piece of that group reflected this fraction. So for example, if we take 1/5, right, that's our proportion of my kids who have polydactyly, and we apply it to, let's say, 10 children, right, then what we get is we get 10 over 5, which is the same as 2. So we've recovered the 2 that had polydactyly by applying this simplified proportion to the total. Similarly, if we apply the proportion of 1/5 of the kids having polydactyly to the situation where I have 100 children, well, that's going to be 100 over 5, which is going to be 20. So in this case, 20 of my children have polydactyly, but that recovers what we had originally here. So essentially, by having this simplified proportion, if we know what the total is, right, if it's 10 children, 100 children, 50 children, we can still apply this proportion and figure out how many of my children actually have polydactyly. So that's kind of our first method that we can use to kind of deal with the simplified fraction losing some information. The second method is to use percentage, and this is kind of where the title of the video comes in, right, how percentage unifies equivalent proportions. And so what we can do is, since we know that 20 over 100 equals 2 over 10 equals 1 over 5. Well, that means that the same percentage will describe all of these, right? Because they're all equal to each other. So conveniently, we have 20 out of 100. We know that that can be converted nice and easily into just 20% because it's a fraction out of 100. So we know that 20% describes all of these. So while 20% doesn't give us the amount of children who actually have it, right? We still kind of lose that information. It becomes more meaningful in the sense that we're using a standardized proportion. It's a value that people are more comfortable with conceptualizing. And so the 20% functions just the same as the 1/5. We can recover how many children it is if we apply the 20% to the 10, right? We could do 20% times the 10, which is going to be the same as 0.2 times 10, which is just 2, or we could apply it to the 100, which is just going to be 0.2 times 100, which sliding that decimal to the right by 2, we get 20. Right, so we can still apply the percent just like we did the proportion of 1/5 up here. Both of these methods kind of allow us to recover what the actual proportion or what the actual amount of kids that have polydactyly are given a certain total. So since percentage can do the same thing, and since percentage is a standardized proportion that the general population is more comfortable with dealing with, right? I think 20% is more illuminating than using 1 in 5. I think it's good to use method 2, but method 1 also works. So this is just meant to further make it clear the application of applying simplified proportions or standardized proportions in order to recover our context. So I hope you found this video useful, and until the next one, you have a good one, you stay groovy. I'll see you then.